This is Structural Analyze and Modeling Portal section Modal Analyze GSA tutorial part. Before you watch this tutorial, it's recommended that you have already gone through the Model Analyze individual assignment and Time History Analyze GSA tutorial. For this tutorial, you should be able to learn how to conduct a simple model analyze in GSA. Here follows the same approaches implemented during the Time History Analyze GSA tutorial part. And in this tutorial, we use the first record in the Model Analyze individual assignment, table 1, for better illustration. So that the mass will be 100,000 kilograms, which is equal to 100 tons. Modulus of elasticity is 2.8 E plus 10 par. And B is for the cross-section size, which is 1.0 meter, and height is for the columns, which is 5.0 meters. Okay, so right now, first of all, let's create a new file and populate the relevant info. For example, in here, we import structural analyze and modeling portal. And for subtitle, we can import like model analyze and click next. So the structure type is space. Unit, we choose kilonewton-meter, and be aware of the unit of length small. And for stress, if you're confused about this unit, you can change it to megapascal or gigapascal. And since in the individual assignment, it just already give you the unit, so you can change it to Newton per square meter, which is equal to the value of par. That's okay. And we don't need to specify any other info. Just click finish. Okay, after we have already defined the first model, what we need to do next is to define the nodal geometry. So first of all, go to the gateway menu and to the node coordinates. We input the coordinates as indicated, which should be 0, 0, 0, and 0, 0, 5. We need 2 columns here to represent the structure. Okay. So that will be 0, 0, 10. Okay, so let's go to graphic view and look at it. We click on label not dots and label not numbers. So we can see we have the first node, second node, and third node, which the distance between each of them is 5 meters. So next we need to link them together to generate 2 elements for the column. So first of all, link 1 to 2, or link 2 to 3. Then we can open the label element number. So you can see that's element 1 and element 2. Then we need to define the mass element, which is go to the gateway menu and click on element. So we select line 3, use wizard. Line 3, we can input number, for example, as in floor 1. The type will be mass, and we want it to locate it at point 2. For this 1. So have a look. We need mass located at point 2 to represent the floor 1 in here. Okay. So we also need to have another mass at node 3. So let's go to that line 4 and do that again. which is floor 2, and type will be the mass, and we want it located at point 3, and click on next. Mass property is still 1 because in this model we only use one kind of mass. So finish. Then we need to generate the support, so we go to the gateway menu, we click on the nodes restraints, and then we need to restrain everything from here in of node 1 as fixed, and for node 2 and node 3 we fix everything except from X direction. And there's an easier way to do that, which is go to graphic view. We use the node selection. We select node 2 and node 3, right click, modify selected node. So we restrain Y, Z, X, X, Y, Y, Z, Z, but don't restrain X. So go back to restraints, gateway menu. So see, that's the restraint condition. Okay, so we didn't restrain the X direction of node 2 and node 3 because we want to see its response at X direction. Okay, then we can also conduct the visual check, which is click on the label restraints. So at node 1 is incasted. For node 2 and node 3 is all fixed in Y, Z, X, X, Y, Y, Z, Z direction, but not X direction. Okay, then we need to define the material properties, which is still go to gateway menu, go to property, and first of all we need to define the material property. So click on property here, user define, because we need to define a zero density concrete, which is not a built-in material in the GSA program. So yeah, let's first select the first line, right click, go to wizard, and copy the name as 0 or concrete 0 density, and material type that should be chosen as concrete. You can copy the short term because when you go here, you can see that the elastic modulus of short term is 2.8 E plus 10, which is same as the first record. Okay. Then we don't need to specify others, but the densities we change it to 0 because we want to zero density material. And finish. So once again, we need to change it here again. Concrete 0 density. Okay. Then the next thing we should do is to define the cross-section property. We should go to section properties and select line 1. We can use the wizard or right click or double click here. So the name we can populate it as column. Then the material, we'll choose the concrete zero density. And then we need to define the cross-section type, which in our case that will be rectangular. And the requirement says is 1 meters. So we can either input 1000 here, or we change the value here to put 1 and 1. And click on next, so that you can have a look at the property, which is A, area, and have a basic idea whether you have input the right value or wrong value. And click finish. Then we define our columns. So since at the elements you see here, the bin 1 and bin 2, which is represent the columns, their properties are both set as 1. Okay, so let's go to the graphic view and open the section display, so we can check we have defined the right things, this column and this column. Okay, so we can close all this. Okay, after we have defined the cross sections, the next thing we should do is to define the mass property, which is here. Okay. Same as we did before, we select the first line, use wizard, and give a name as mass. Mass value should be aware that the unit here is ton, so that for our case, which is 100,000 kilogram, that will be 100 ton. Input the value and press OK, and then we generate the mass property. Okay. So there's one thing to mention before we move on is that this is a very easy model. So we follow this procedure. We first define the material, then we define the cross section, mass properties. But if you are conducting a more massive or much bigger structure, you may need to use much more different section properties and maybe some more materials and more mass properties. So it's usually a good idea that you define them first. For example, column for the ground floor, column for the first floor, and beam for the first floor, beam for the second floor, and then you open the data defaults, go to elements, and change the property when you draw the elements here, so that you don't need to, for example, select them and modify the selection element and change the properties. But of course, in this case, we only have one property, so you don't need to worry about that. Okay, so the next thing we should do is to calculate the model property. Just go to the gateway menu, cases and tasks, analyze task. So we can right click here at new analyze task, or we can click the new analyze task at the top toolbar. So we give the name as model analyze. Click on model. Next. So the number of modes right now there will be 2 because we have 2 nodes. And then we can click on next. You don't need to change other values, but it's recommended you should use help to have a better understanding about what do they mean in here. Okay, so we go next. We start to analyze it. Just click on finish, and we finish analyze. So we go to the output, or we go to graphic view. Click on the default image. So have a look at its period and frequency. Okay, so you should compare the results to hand calculations, and well, it seems it's not doesn't look very well. So we can have a look that in mode 1 the period is 4.408 Hertz, and frequency stat period is 0.2268 second. For the second mode, there will be that. The period is 0.08665 second. Then we need to plot the nodal displacement. If the period you calculated is correct, or corresponding to what you have calculated by hand calculations. So we go to the control settings here. Okay, we click on all the results, and right now, first of all, we need to see the how the motion is. So we go to displacement. We click on the translation UX because we want to see how it behaves in X directions. So you should also choose the controls based on actual values, so you can read actual values from here. So here is 1 meter, and here is -618. That's for mode 2. Okay, so you can see that's how it looks. They are go to the different directions. And for mode 1, here is 1000 millimeter. Here is 618 millimeter. Okay, so then you can record these values in Excel or other documents and compare the results to what you have done in hand calculation. And if you are not sure about whether the value is, well, just like it said, you can use the select for animation tools on the left hand toolbar and select them. You can see here is 1000, here is 618, and at mode 2 here is 618, here's 1000. Okay, so then you can be sure about the value. Okay, that will be all for the model analyze GSA tutorial part.